Thank you, Martina, for the warm welcome. Before I start with the first presentation, I'd like to say a couple of welcome words or introductory words, also a couple of maybe logistical administrative things for today. And actually also for tomorrow. As you might have just heard, the sessions will be recorded. The plan is to make these public sessions available to you so that you or even colleagues of yours might have the chance to look at it afterwards at your convenience. I think some of the sessions, many of the sessions actually have demos integrated in there, and I think having a chance looking at the demos afterwards, some of them gonna go very quickly, some will be potentially in terminal views, and that stuff is not in the PDFs. PDFs also will be provided for this session, so the plan was to have all the PDFs available to you. I think this morning there were one or two still missing, so I hope latest before they start, they will be made available. So you can have a look at the presentation material on the fly, respectively, also at your leisure time. Let me go a step further and talk a bit about goals and objectives, at least from the Intel perspective. So we would like to get out of it and provide to you our particular insight into heterogeneous programming with Intel hardware, by using the Intel One API development tools, which are the core of these 2 days session. We have a lot of internal speakers and specialists, tool specialists to be precise, and we also have an external speaker, one of the GROMAX developers, who's going to share his insights by working with One API tomorrow. I would wish if we have an interactive session as much as that is possible in this virtual environment. So we have, as you hopefully can see by looking at your screen, through WebEx, the capability of a chat room, which we're going to monitor. There is typically one Intel person assigned to look at it in order to answer questions that you might have in real time. And we also take the liberty checking at each session if there's some unanswered stuff in order to respond to it. I think I mentioned already earlier, this is a public event, public in the sense of there is no confidential material in here. It's dedicated for the data centers, which are part of the EuroCC activity. And for that purpose, we also can provide it publicly. So don't expect any confidential material. I know a lot of you have direct contacts to Intel, to various Intel people. So if you have a need for confidential information, so I'm thinking about upcoming new features, roadmaps, for instance, feel free to contact your respective counterparts. And if needed, you can also contact me. My name is, as you see from the agenda, Edmund Price. Together with a colleague of mine, his name is Vladimir Kostarev. We are covering business development issues across EMEA, across Europe, if you like. Regarding the agenda today, and then I'm already through with the intro and gonna go directly into the first session, which is an introduction about the new development environment, about heterogeneous programming, about the One API standardization initiative. So that's what I'm gonna start with. Klaus Dieter, my colleague from the technical side, gonna give a short introduction on the Dev Cloud. That is kind of a sandbox where you can have access to hardware Intel hardware and to the One API development kits. Igor gonna follow up, and that will be one of the core elements of today's session, talking specifically about the direct programming models for heterogeneous programming, with a lot of demos being integrated. Before I continue, for everybody, I hear some voice in the back. If you can switch off or mute your micro, I would appreciate. It's a bit disturbing once in a while, particularly for the listeners, I guess. So please mute yourself unless you have a need to speak up. Igor gonna continue with the compatibility tool. That's a tool for migrating CUDA-based code to the DPC code that he had talked a bit earlier in his core session. Gennady gonna follow up with the Intel libraries. Alina gonna talk about debugging tools, and Shailin will have a session about an hour or so, where he will talk about the Intel One API analytic toolkits, which I'm gonna touch on very, very briefly in my introductory session. So I think I'm gonna switch off the video right now. Sometimes I've seen in the past that videos and the connectivity sometimes was impaired by that. So hope you don't mind. So let me start then with the first session, which gives an overview of the Intel One API industry initiative or standardization effort, and also about specifically the Intel One API toolkits. So let me start with the statement about, or the problem statement to be more precise, what is happening these days, or for the last few years already in the industry. When it was about programming, a lot of people in the past were using just CPUs. The x86 architecture played a central role in that. In the meanwhile, the market is much more diverse beside the CPU, and because of performance enhancements, graphical processing units, GPUs or discrete GPUs have been added to the market. FPGAs have been integrated into the concept of accelerated programming. And there are even other accelerators. Think about AI accelerators from Intel and other players in the market which are available. For all of these hardware elements, you need a software development environment, each of them being different, each of them requiring you to learn a new tool chain, which can be not only cumbersome, but it's lengthy, it's time consuming, and at the same time, it also costs money to learn many of these new things. One API is an effort and has the intention to overcome the problem that I was talking about earlier by providing, first of all, an industry initiative, call it standards, would call it also One API, in order to provide a unique set of tools that can be used, that you see that on the right side in the stack here, across all hardware. And it's not limited just to Intel hardware. The concept and the perspective behind it's addressing all hardware. And I'm going to show you a couple of examples where we've seen already that other players in the market are jumping the bandwagon. In terms of the One API industry initiative, where Intel and other industry players have joined and meet each other, by the way, also on regular basis in order to drive the industry standard. The One API is standard forward. There are for programming, for direct programming, but also for the libraries, so-called advisory board, technical advisory board, TABs in place, where people meet from the industry in order to talk about longer term enhancement. The industry, there's an industry specification. I have a separate slide if you are interested in details with a lot of links that you can go to and learn more about it. But high level perspective, as it's shown again in the stack model here on the right side. The core part is the direct programming model. It is data parallel C++. I have a separate slide where I'm gonna provide a little bit more details about it. The other thing are the standardized APA-based programming libraries which are widely used for heterogeneous programming, math libraries, threading libraries, deep learning neural network libraries, machine learning libraries, communication libraries in general, and also video processing libraries. I mean, we all know for developers that developing a program is good, and for that reason we need a compiler. But a developer also wants to move ahead very quickly, and his intention should be, to a certain extent, even to be lazy. And for that purpose, that's what libraries are good. Don't reinvent something that exists already, where somebody else has put a lot of brain and thoughts into it and has come up with a great solution that is typically also faster as individuals can come up with. The third part of the industry specification is a low-level hardware interface, which bridges the gap between the direct programming and the libraries towards the individual hardware, also specified. Here is what I was promising a little bit earlier regarding one API, the industry specification. When you have the PDF in front of you, you can click on it and it will lead you to the next level where you can find much more information about it. So let me move on to the next slide. I promised to talk a little bit more about data parallel C++, which is a core element of the One API standard. As the word says itself already, the C++ standard is based on the ISO C++ implementation. So you need a minimum the ISO 2017 version of it. The industry and the Kronos group was leading providing an extension of C++. It's a template-based approach called SYCL. I guess many of you have heard about it. So SYCL is the approach to offer for developers a C++-based environment that allows heterogeneous programming. There are community extensions to it, and there were a couple of extensions which were missing initially, and the Intel DPC++ implementation was offering some of them. I think the one most notably to mention here is the Unified Shared Memory extension, which was not part of the Kronos SYCL initial standard, and we provided a first implementation. It was one of 6, 7, or 8 different extensions which were provided. Many of them made it into the One API standard, and many of them, by the way, are already in the meanwhile implemented in the Kronos SYCL standard. As I said earlier, Intel has a DPC implementation, and the DPC++ implementation aims to be the best implementation of SYCL. It's not the only one. There are in the meanwhile other SYCL implementation, which is substantiating that this is an initiative that obviously has led to a lot of interest in the market, a lot of support in the market. I'm going to show a few examples later on where this stuff is a bit more substantiated. Regarding the API libraries, I think we can skip over this slide relatively quickly. It shows the major One API library examples, which are part of the One API standards. I mentioned most of them. I don't want to repeat them here. In terms of the One API ecosystem that has been developed over the last, I would say, 2.5 years since we have announced One API initially to a lot of customers, by the way, also vendors out in the market. Many people see a high interest in One API and supporting the One API ecosystem by spending time on porting applications to One API, for instance, using the One API Intel toolkits implementation, or coming up with own implementations in the market. I don't want to kind of pick any of these accounts here. It has become a long list, and it's a growing list. I mean, these are just people who provide us their okay to allowing us to show their names, showing their support for the One API initiative. There are actually many more which are not listed here. This open ecosystem or accelerator ecosystem is growing. I'd like to focus your attention on the left side. You see a list of activities and companies and hardware vendors, architectures which are supported. One of the key players in the market is CodePlay, a system integrator operating in the US, but also here in Europe, that jumped the bandwagon very, very early with contributions to DPC++ and to SYCL. Even for NVIDIA hardware, we have One API, specifically the One API DNL library, which is used in the Fugaku data center in Japan on an ARM technology. Huawei with their AI, with an AI chipset, is using DPC++. CodePlay again is further down, has certain projects in place with key players in the market, with Argonne National Lab, NERSC, and a few others, where they're supporting again NVIDIA hardware, even AMD GPUs. And regarding the European exascale project, CPERL's CPU, which is again a non-x86 architecture, ARM-based architecture, together with support for Intel's Ponte Vecchio chip, also supporting the One API standardization and ecosystem. There are also a couple of examples of applications which have been ported. Here is an example on the right side. The picture is trying to describe it very nicely. It's tsunami simulation, particularly here in the Pacific. The leading company here is the SUSE Institute in Berlin, which started the porting of an originally CUDA application using one of the tools that we're going to spend a bit more time later on, the One API compatibility toolkit, which was used in order to migrate the CUDA application to DPC++, running it on various hardware and including running it backwards also on the original NVIDIA hardware where it was coming from. The interesting thing was that the performance that they gained using One API's DPC++, Intel's DPC++ implementation, they got 95% of the performance of the original NVIDIA application, the hardware, comparing of the same hardware that they started from, which I think is a good testimonial and testimony for the effectiveness of the system. And the SUSE Institute was also very pleased that they got within 5% of the original performance. These applications like this one are even further developed, will be rechecked when latest hardware is coming. newest hardware is coming, and then benchmark will be made available. I talked already a little bit about the Intel One API tools. Here is kind of the official start within my presentation set where I talk about the One API tools. So these are the One API toolkits, which are comprising of the compatibility tool suite, the language, so DPC++, but also Fortran and others, the libraries, and a couple of analysis tools that many of you who know about our past bundles called Interparallel Studio probably are aware of. I'm going to spend a few words on it, and we have 2 sessions at least where we talk about that. So this is here in the middle of the stack, the Intel implementation. And what we have here underneath, this means the Intel hardware, which is supported by the Intel One API toolkits. I mentioned the DPC++ compatibility tool. It is a migration tool from CUDA source code to DPC++ source code. The idea is to automatically migrate about 90 to 95% based on our experience to DPC++ code. So this is human readable DPC++ source codes with inline comments, which helps to address open issues that the developer has to complete the coding process, tune it for desired performance, and then have his DPC++ source code. The analysis and debug tools, as I said, many of you might have heard about it. There's a debugging tool, an interdistribution of the GNU debugger. There is an advisor tool specifically for performance analysis, a performance analyzer originally used for the vectorization, so SIMD instructions on Intel CPUs, has received in the meanwhile additional functionality that helps to analyze efficiently offload code for GPUs. As I said earlier, we have a session on it. The vTune profiler is a performance profiler, originally coming from, again, from the CPU, helping you to identify performance bottlenecks, and also giving you insight in with the performance profiler, a system profiler, giving you insight in the overall system and inefficiencies in the system and HPC system, for instance, and now also being extended to GPUs and FPGAs for performance analysis. This is the overview of the One API toolkits itself. There is, and I have a separate slide that talks about more details about that, where we see the individual components high level. There's a DPC++ compiler, the compiler in there, Python compiler, vTune is in there, and then there are on top, that's here shown in the middle, specific domain-specific toolkits. For, I think, most of people here on the call, the HPC toolkit are the most relevant one. So it works in combination with the base toolkit. So you download the base toolkit first, and then put the HPC toolkit on it. And as I said earlier, we're going to see one slide that talks about the individual components, and we'll give you an overview that this provides you everything that you need to have in a data center, an HPC-based data center, high-performance data center. There are additional toolkits. I'm going to have a slide each for rendering, and for the analytics toolkits, the IoT, so for, let's say, embedded environment, for edge programming, there is a toolkit, the Internet of Things a toolkit, which exists also on it. And for people who also do deep learning inference, there is an OpenVINO toolkit that typically is addressing the needs of a developer who takes his trained models and integrates them into embedded solutions at the edge. Yeah, here is the slide that I was talking about earlier that gives an overview of the base and HPC toolkits. It has different colors and boxes. The light blue one is, so all the stuff that you see here, categorized by direct programming languages, the APIs, so the libraries, and the analysis tools. So the light blue shows the components which are in the base toolkit, and the dark blue are the extensions here on top coming from the HPC toolkit. For those of you who are interested how that compares to the Parallel Studio components, they are encircled here. The boxes are surrounded with these yellowish type of color. So these are the components that you know from the past. And particularly the new stuff coming with one API is encircled or surrounded by these light blue lines here. Yeah, I think this is the high-level overview. We're gonna talk about these individual components in the next today and in many sessions also tomorrow. So let me not dive deeper into it. Let me, in the last couple of minutes that I still have, talk about the additional toolkits which we have added relatively recently to the One API toolkits. One is the rendering toolkit. So the purpose of that rendering toolkit is to provide visualization tools to provide high performance, high fidelity 2D and 3D images. There is a plethora of libraries that you find here on the right side with some pictures to it that gives you an idea what it's about. At the end of the day, it's about rasterization, rendering, and very photorealistic ray tracing libraries. And some of them even, like Osprey, for instance, for distributed programming or distributed usage in a data center. We have one session today about the One API Analytics Toolkit, so let me touch on it very high level only. Basically, it consists of data analytics functionality, so there's pandas in there, for instance, but there is also an interdistribution of modem, which is like pandas, but it's for distributed systems, so you get much more performance. Data analytics is much faster. There are classic machine learning activities. There's an Intel extension for scikit-learn, which is about 100 times faster than the plain vanilla scikit-learn implementation that you can download from the net. There's also an Intel optimized XGBoost implementation there. And for those who are interested in deep learning and deep learning training specifically, there are frameworks, TensorFlow, PyTorch, which are also optimized and giving 10 times performance over the non-optimized versions. Where can you get the One API toolkits? Yeah, basically they can be downloaded. There are repositories, there are containers. Go to the links here. You will have it, as I said earlier, should have it available. So when you click on the links, that gets you closer. The next session from Klaus Dieter will talk about the Dev Cloud, which is a sandbox. We'll not dive deeper into it. I talked about the toolkits. Here is the key message. Many of you probably know the Intel Parallel Studio bundles, the Cluster Edition, the Composer Edition, the Professional Edition. All these features are integrated, the compilers, the classic compilers, into the HPC and base toolkits. So stuff is still available with the new toolkits. I don't want to go in all the details. The key message of this slide here is the One API toolkits typically have a major update every year. So typically by the end of the year, beginning of the year. Currently, we're in the One API toolkit version 2022. And the current update is the .1 update. Every quarter, there's typically a new update. And focus of the new enhancements are cross-architecture programming, performance, providing new features like if new instructions, for instance here, like for Sapphire Rapids, which is the latest Intel CPU with the AMX features, all of that stuff is integrated. So if you use the latest One API toolkits, you have that functionality and can program with it. Yeah, so let me move on. Here are a couple of examples. I mentioned the EasyWave application from SUSE Institute, but there are a couple of others. CERN is another customer that's using One API, very intensive. There are currently, and you can find that on the website, Intel has a One API catalog with applications using One API. Many of them have really ported already to beyond x86, even to GPUs, integrated GPUs, FPGAs, and so forth. CERN itself has 6 applications that have been ported already. All of that stuff can be found there. GROMACS is another example. One of the leading stakeholder there is Eric Lindahl. There is, if you click on this, there's a video behind it. I will not open it given the time constraints that we have. Feel free to have a look what Eric has to say about One API, about the benefits, some of them that I've mentioned, but I think he has even a bit more. And you get a view from the developer perspective. There are a lot of resources out there in order to get started, a lot of links that you can use about the initiative, about the toolkit, about learning and training and webinars. There are a lot on the web beyond this. And as I said earlier, these 2 days will be recorded and will be made available to you so that you can have a look at it as your leisure time. And with that said, I'm running a little bit over time, a bit 4 or 5 minutes over time. So let me sum up very quickly. So what we've seen is that Intel One API is an approach for addressing with one initiative, with one set of development environments and tools, cross-architecture programming. So you have the freedom of choice. The products that Intel offers are covering accelerated compute, CPUs, FPGAs, and we are constantly evolving this product to enhancing it, providing the features of it, and providing a complete set of software development tools for HPC programming. So with having said that, as I said, I'm a little bit over time. I'm gonna conclude and stop here. If you have any questions, feel free to use it in the chat, and we're gonna answer it. So with having said that,